Hello, my name is Nigel Arnold. Today I'm bringing you a video about how to frame a distant nebula using Astrophotography tool, APT. And the reason I'm bringing you this is, just for a bit of background, about 2 years ago I started in astrophotography by buying a Canon DSLR, pointing it in the general direction of Orion and taking some snaps, and was hooked ever since. Today I've got a Skywatcher go-to mount, a ZWO cooled 071MC one-shot color camera, and I use a Sigma 150-600 lens. I don't use a scope at the moment. And I started off taking shots of galaxies, and that was relatively straightforward in terms of finding them. So even without doing any star alignment, I could use facilities within APT to find the galaxy and get it centered fairly quickly, because pretty much you could see it on screen, even if it was a distant smear. You sort of knew that was what you were framing. And then earlier this year, I started, when I got my ZWO camera, I started to look at shooting Nebula. And the first thing I tried was the North American Nebula. And this is the result of that. What I found is that what I thought I was pointing at was indeed the correct nebula, but I basically got just a very thin sliver of it. So what I'd started to look at is how best I could improve that, and with a few tools and a few pieces of software, I found I can much better frame a distant nebula that you may only take a 10-20 second exposure as a test shot to know that what you're looking at is what you're going to get. So without further ado, let's start off. So there are three things we need for this. I'm assuming that you're using a laptop or some Windows-based device that is connected to your mount. I use a Windows laptop, and I use ASCOM and EQ mod to allow me to control my mount. As I say, the video is around APT, Astrophotography tool. I'm sure this is capable in other pieces of software. At the moment I only use APT, so that's what the primary focus of this video is. We need two other pieces of software to help us, and you may already have these installed because they're quite popular. The first one is Stellarium. So Stellarium is a planetarium piece of software. Lets you look at the night sky any time of day, any day of the year, and you can do some quite neat stuff with Stellarium. So you need to download and install Stellarium. And once you've got that installed, there's a couple of things we need to configure. So I'm going to launch it and show you what those items are. It's basically two plugins. So when Stellarium starts, it shows you your current time of day. So currently it's still daytime, but don't worry about that too much at the moment. So as I move the mouse over to the left, we get a pop-up toolbar. So we need to press the spanner, which is titled Configuration Window. And then we go to the plugins. And if we scroll down to these list of plugins, so all these are the plugins that came with Stellarium out of the box. There are two things we need to enable. The first one is called remote control. So we need to make sure that load at startup is ticked. And then if we hit configure, we've got server enabled ticked and enable automatically on startup ticked. The reason we're doing this is APT, Astrophotography tool, needs to talk to Stellarium, and this is how it does it. Don't worry about the IP addresses and everything like that. As long as you've got these options enabled, we're good. The second thing we need to do is we need to configure the Oculus plugin. And again, load at startup. And what the Oculus plugin does is it lets you map your camera and its sensor size against the focal length of your scope or your lens. I'll be using the term lens quite a lot because I don't shoot with a scope, I shoot with a Sigma 150-600. So first of all, we go to the Sensors tab. Sensors is your camera tab. So in here you define the cameras that you use. I've got two. I've got my old Mark III, my 5D Mark III, that's a DSLR, and I've got my ZWO 071MC. And what you need to provide against these is the specifications. So we've got the pixel size in X and Y, we've got the chip width, and we've got the pixel width in microns. All this information you will find on the manufacturer's website, various PDF manuals. It's not difficult to find these figures for the camera that you're using. So I've got both of mine set up. One thing to point out is you'll see later when we tell APT about these sensors is they're numbered from 0. So this is 0 and this is number 1. The image that we're going to be looking at I took with this ZWO, so you'll see that I'll be referencing sensor number 1 in my APT setup when we get onto that. The next thing you need to do is define your scopes. As I say, I'm not using a telescope, but it's basically the focal length of the optical tube that you use. So I used a lens. And again, you define your lenses in here. I did my shots at 600mm, so I've got a setting here for 600mm. I've given the name of the focal length just for I can easily see it, and a focal length of 600mm, and then the diameter is for lenses you can take basically the thread size at the end of the lens, which on a Sigma 15600 for what I use is 95mm. I've defined some others. Again, these are numbered from 0, 1, 2, 3. So based on what I've said, we're going to be choosing sensor number 1 and telescope number 1, which is my 600mm DSLR lens. Now that's all I need to configure, or you need to configure in Stellarium. One thing I'm just going to need to do, but you won't need to do this because you'll be doing it outside at the correct time live. I'm not, because it's demonstration. What I need to do is I need to basically push this forward so it's dark, roughly around the time I took my picture, and I actually took it on the 6th. As I say, you don't need to do this because your time and date will be right for what you're currently shooting. And then I'm going to minimize that. The next tool you need is All Sky Plate Solver. So what's plate solving? Plate solving it's a very complicated process, but it's very easy to describe. Plate solving is the art of showing some software a picture of the night sky and it working out what you're pointing at. And the way it does that is it takes various parameters such as your focal length, in my case 600mm, takes your pixel size, in my case 4.78, and it downloads when you install this basically a load of files from a site called astronometry.net, and it stores those, and Plate Solver will use those to work out the image that you fed it against what you're looking at. I'll show you what All Sky Plate Solver looks like. A very, very simple interface, and when you first start this you'll be actually offered this, the installation wizard. Mine's already set up. Ignore this one at the top, it's just something I was experimenting with earlier. And what I did was I told it my focal length and I told it the pixel size of the camera that was used. A really easy way is you can basically feed it a FITS file that you've taken at the same length, same focal length and the same camera, and it will work these values out for you. And then what it will do is it will go away and work out which of these index files it needs for your camera and your camera's focal length. As you can see, it picked these for mine and installed them. Doesn't take long, they're not very big. The biggest one there is 116 meg. And that's All Sky Plate Solver configured. So we'll come out of there. So the next thing we're going to do is how do we glue all this together? So in APT, one of the first things you need to do, if you've not done already, is you need to configure your planetarium software. So over in the Tools tab, there is APT settings. And then when the settings dialog appears, you pick Planetarium. And it has built-in support for Stellarium. So I've ticked that. This IP address here is basically the loopback address of this machine, so you just leave that. If you're running it all on the same box, you just leave that as 127.0.0.1. The port number, unless you changed it during your Stellarium plugin for remote control, it defaults to 8090, which is correct. And then, as I mentioned earlier, the numbers. So my camera, my sensor was number 1, the ZWO, and my telescope, my lens was number 1, which was a 600mm definition. And that's APT configured to use Stellarium. You'll notice, because I launched Stellarium first, down here in APT, when it launched, it said connected to Stellarium, which is a good sign. So as far as APT communicating with it, all is good. So let's imagine now you're in your backyard, you're at your location, and you can have done a star alignment. That's entirely up to you. I just plate solve. But when you take a picture of some nebula, it can be really difficult to know what you're pointing at if it's not a clear definition. So the American Nebula is a classic one because it's quite a vast nebula in the sky, very large. And what I'll show you is this is a picture I took on the 6th of the 6th. And it was my first ever nebula picture. And I got giddy because, hopefully you can see on the video, I can see some of the red emission down here, and I was right, we've got it. And off I went and did an hour's imaging session. The result of that imaging session was this. And I still wasn't disappointed, but let's say a schoolboy error. Apologies, let me find it. I'll come back to that. I'll show you what the finished picture, in fact, is it in my pictures folder? No, I'll come back and show you what it actually looked like. So what we need to know is, and of course this could have been a 10-20 second exposure, is I want to now know that I've got my nebula framed, ideally in the middle, and I've maybe got the right focal length. I want to see what this is going to do, what this is going to turn out like when I process my images that I'm going to spend potentially a long time doing. And what APT has is a fantastic piece of built-in software called PointCraft, and it uses All Sky Plate Solver and its own routines to work this out and ultimately talk to Stellarium. So I'm going to hit Connect Scope. I'm not actually outside, I've just got a simulator running. Probably don't need to do that, but it's just a matter of habit, I do. So let's imagine we've just imaged this in the back garden, and we're not sure what exactly we're pointing at. We know we're in roughly the right area because I can see something. So what I can do is hit PointCraft. Now the first time you run this, you'll need to go into the settings. It may even prompt you to set it up if I remember rightly. And what it wants to know is where you've installed your plate solving software, and it supports two. It supports PlateSolve 2 and it supports All Sky Plate Solver. So I simply browsed to the location where All Sky Plate Solver had been installed. And that's pretty much it. So cancel out those settings. So back to our scenario, we've just taken this shot and we want to know what we're pointing at. So we hit the blind button, and what that basically does, it does a blind plate solve. So we haven't told it, the software, where we're pointing. All we've said is, here's an image, go work out what this is, please. And what this will do, if everything's set up correctly, is within about 30 seconds, again, times differ depending on how complex the image is. But great, it says success. So basically it knows approximately the right ascension, the declination of where this is in the night sky. And here's the clever bit. What we can now do is say, okay, well, show me this in my planetarium software. I want to see what this image is. So hit show. Down here you'll see a status is just updated to sent to Stellarium the field of view, orientation and telescope image position. And fingers crossed, if I now go to Stellarium, it will have shifted the field of view in Stellarium to where that image is pointing to. Now obviously Stellarium has the nice image of what the nebula looks like. So it's like, okay, if I'd have known this before I'd started, I know that I'm off. But this is the whole point of this video. So the orientation is slightly off. That's fine. So I'll show you what this edge here is actually this edge here. This bottom edge is this bottom edge. And the reason I know that is if you look for this black part of the nebula, it might not show up very well, but it's actually here, and I can see that with my eyes. And obviously I can see that very bright star there, which is Sig. Is it E Sig? It's got a symbol and a Sig. I'm not sure what the symbol is, but that references that star there. So there's a couple of things here. One, my focal length. Before I go on, you'll notice that Stellarium's picked the sensor and the telescope that we told it in APT. So that's the camera I used to take the picture. That's the focal length. So there's two things wrong. I'm not in the best position, and I'm far too zoomed in. So one of the things I can do in Stellarium is I can actually cycle through my lens sizes that I defined. So let's go back to 400mm. Maybe 400mm would be good, but if it was maybe there, or maybe even wrong way, maybe even 200mm would get more of it in. So again, it's helping me decide what focal length. And again, I should have checked this before, but sometimes you get a little bit carried away when you're imaging, and these are all things we can learn from. So back at what I actually took an image of was there, and let me show you the image. So this is the image that I processed. So I'm still fairly happy with it, albeit I'm missing loads of it. And if I angle it at the same, I don't know if you can get these on screen at the same time, you can roughly see. That didn't work very well, did it? So when we first did the, it was approximately there. I could go through it again, but in fact, let's do it. Let's go into here and hit show, and it'll reset the view. It's pretty much 600mm, so we can see where we were. And if we look at my processed image that I've tried to angle, it's pretty much bang on. So hopefully that will help you when you're framing up your deep sky nebulas that are very faint on your test shots. And you don't even have to take a 5-minute exposure. You can take a 10, 20 second, 30-second exposure. As long as your plate solving software can see some stars, it will then show you in Stellarium what it's looking at. We may as well talk about another great feature. So if I'd have realized that I'm pointing at the wrong part of the sky, not the wrong part of the sky, but the wrong part of the nebula that I wanted to take, I'd have obviously reduced my focal length. But I could also use this fantastic function APT called go to plus plus. Once you've solved an image, what you can do is press aim, and you can press anywhere in the image. So I know this is the edge of it, so if I click here, if I was to then hit go to plus plus, what would happen is the mount would move to where it thinks this is approximately from the center of the image. Take another image and solve it, and then show you it again. And again, once it's synced it and showed you the coordinates, you could hit show in PointCraft, and it would then re-show you in Stellarium what you're now pointing at again. So usually within about 5 minutes, you can have that very faint nebula that you've taken your test shot on pretty much lined up bang on as to how you want it. Obviously, I said with galaxies, you don't really need to do the show because you can usually see in your test shot the galaxy. And you can can usually get that centered up really quickly. So hopefully you found this video useful. I'm hoping to do some other astrophotography videos with some tips and tricks I've picked up. I say far from an expert, very much a beginner, but I do like to show anything that I've learned that I think other people will find useful. So yeah, thanks for watching, and if you want to subscribe, my channel's a bit of a mess. We've got some gaming videos in there, we've got some drone videos in there. I should really relaunch just an astrophotography one, but we'll see how it goes. So anyway, thanks for watching, and clear skies.